This video tries to explain some important aspects of Spark structured streaming. Let's understand how reading and writing of data happens with the use of Spark structured streaming. Suppose we have a set of files stored at some storage. When we set up the streaming on file source, what Spark does is try to explore the folders and files at the source and fetch metadata information like file path. This process is known as file listing. Once it collects the file listing information, Spark tries to make execution plan for the actual processing. The workload is then distributed across the cluster for processing. Finally, the process data frame is saved to some storage location. Now, let's understand some out-of-box options as provided by Spark structured streaming, which can be utilized based on use case. First, max files per trigger and max bytes per trigger. They're used to control the amount of data in a single micro batch. These options are very useful, especially when dealing with large data sets. By controlling the micro batches, we can avoid out-of-memory issues while execution. Please note that these parameters might not be applicable to all the use cases. Moreover, we can utilize options like for each batch to execute a custom piece of code on the data frame in each micro batch. Apart from this, Spark structured streaming also provides checkpointing mechanism to store the state so as to provide seamless failure recovery. There are a lot more options that Spark structured streaming provides, like recursive file lookup, path glob filter, etc. Now let's take a look at some implementation details using PySpark. Spark structured streaming has two parts to it: read stream and write stream. First, we set up the data frame stream using read stream and then utilize the write stream to perform data transformations and finally save the results to some location. Now, let's take a look at an example on how to read and process source files using Spark structured streaming. First, we will use read stream in Spark. Then we can specify the format of the source file. It can be text, Parquet, binary, etc. For this example, we will take binary as the format. You can then specify the schema if it's applicable to the file source. It essentially would represent the schema for the data frame. Then, as we discussed previously, we can use various options like max files per trigger, max bytes per trigger, path glob filter, recursive file lookup, etc. based on the use case. In this example, let's just use max files per trigger, and other options can be used in a very similar fashion. Here in the example, we specify the max files per trigger as 100, which means it will try to process only 100 files in a single micro batch. Finally, we load the source files by providing the path to the load. Then comes the second part, write stream. We specify the format. For this example, let's use delta as format. Now, the trigger part, where we specify the interval after which we want to read the source. In case of changing or incremental load, we would want to keep the processing, let's say, every 10 minutes. We can use appropriate option to specify that. In this example, we will use available now trigger, which will basically pick up all the files available at the moment streaming is set up. We can use options like checkpointing by passing the location where checkpointing metadata would be stored. There is also a provision to run some custom piece of code on each micro batch using for each batch. You'll get data frame and epoch ID as parameters which you can pass to your custom function for processing. Epoch ID represents the micro batch number, which is usually utilized for logging purposes. Thank you for watching the video.